Night hangs over a quiet universe, a velvet expanse pricked by cold stars. And somewhere in that depth, a question turns like a slow comet. If black holes are mouths that swallow light, could there be their opposites? White holes? Fountains that nothing can enter and everything must leave. A mirror to gravity's most secret appetite. A riddle written in the negative space of space-time that waits for a listener who can hear the silence it makes. Black holes we know by their shadows and their heat, by stars that orbit empty gravity, and by ripples in space-time that ring like struck bells. But white holes arrive first as a whisper in equations, a time-reversed solution that seems to exist the way a reflection does, present only because something else stands before it. And yet even reflections imply a surface, a place where the world changes direction, and hints that symmetry might be more than math's private dream. Einstein's field equations accept more than one story, and in 1916, Carl Schwarzschild slipped a solution onto Einstein's desk like a precise seed, a geometry with an event horizon that later generations would extend and interpret. And when that extension arrived decades on, with Kruskal and Szekeres drawing maps where horizons and infinities arranged themselves like a deck of careful cards, a new region bloomed that expelled geodesics as surely as black holes consumed them, a theoretical territory we named white hole, for the way it burns the arrow of time. On those maps, the black hole and its white twin are joined by a throat, an Einstein-Rosen bridge that resembles a wormhole for the length of a thought, a tunnel you could imagine crossing, if only the tunnel did not pinch and flare too violently for matter to survive. An instability like a heartbeat racing toward collapse as soon as anything tries to enter. A hint that nature allows elegant corridors on paper, but populates the real corridors with collapsing ceilings and alarms that never stop. Still, the possibility lingers because nature enjoys extremes. And at extremes, physics grows plural, classic, and quantum voices, arguing in a cathedral of curves, where light rays obey geometry, but particles remember uncertainty. And in the back of this hall, a suggestion stands that time itself may be a negotiable treaty, and that the white hole is not merely black hole in reverse, but a different kind of boundary condition, a rule at the edge that writes its own exceptions with careful ink. The trouble, as always, is evidence. For telescopes find the marks of black holes' disks of incandescent matter, jets lancing space, stars whipped by invisible partners, but not the signatures of white holes, unless some transient we already catalogued wears an unfamiliar mask, a flare we filed under unknown. That was in fact a brief and perfect exhalation, a suggestion that what we seek might already be in our possession, but disguised by our expectations and the romance of tidy names. In the mid-century glow of new mathematics, Penrose diagrams compressed eternity into manageable triangles where light moves at 45 degrees and singularities look like walls you cannot paint through. And within those triangles, both black and white holes take their places with a calm that feels like law. Yet physics beyond the sketch warns of Kachi horizons that amplify noise into storms, inner regions where predictability breaks and the slightest perturbation becomes fate. A warning that whatever white holes are, they do not like to share a universe with our kind of disorder. Charged and spinning black holes, the Reissner-Nordstrom and Kerr families deepen the labyrinth with inner horizons and potential exits that look for a moment like white doors. And those doors lead to other universes and extensions, so maximal they feel like myths trying to become roads. But the moment we add dust and light and ordinary tremors, the corridors fracture into turbulence, a hint that pristine geometries exist only under vows we cannot keep, and that the white hole might be a perfection the cosmos keeps behind glass. And yet the universe began with an explosion that was not an explosion, a rapid expansion that turned a smooth beginning into a canvas of galaxies. And some have asked whether that beginning, viewed from another angle, is a white hole's outflow, a cosmic event horizon crossed in reverse that birthed the sky we now inhabit, a symmetry proposal that rearranges causality without violating it. And the idea lingers like the scent of rain before a storm you are not yet sure will come. If the Big Bang is not a firecracker, but a boundary condition, a place where our equations falter and restart, then white holes invite themselves into cosmology as metaphors and maybe more. The suggestion that elsewhere, in a larger architecture, a black hole collapse could tunnel and reappear as a white hole expansion. A parent universe feeding a child universe through a bridge, so brief no clock could learn it. An idea both audacious and soothing in the way it has destruction into transformation. All this would be scholarship in a drawer, if not for the stubborn fact that black holes evaporate, at least in theory, leaking quantum heat that slowly eats their mass. And a handful of thinkers have wondered whether the final whisper of evaporation becomes a pop of release, a white hole remnant that disgorges information or energy in a last burst, tiny and fast and easily missed against the lively background of a noisy sky. A scenario that turns the end of a black hole into a new beginning with good manners. From quiet rooms where chalk dust rises like nebulae to radio dishes that harvest electricity out of ancient lightning, the hunt is gentle and patient, and in that patience lies the hook that holds us. Because a white hole is not just a phenomenon to catch, but a test of how we think about time, about symmetry, about whether the universe prefers endings that fold back into starts, and if so, whether we have been living alongside the evidence without knowing the sound of its breath yet. Before astronomers pointed arrays at the Milky Way's center and caught stars slingshotting around an invisible anchor, white holes had already walked out of the blackboard as obligatory partners in a fully extended spacetime, an insistence of integrity by the equations that said if collapse creates a one-way surface, then expansion creates its complement, a demand that balance be preserved in a way that is mathematical rather than moral. And this austerity has a beauty that breeds loyalty. The Kruskal-Szekeres extension is a cartographer's dream, removing the coordinate kinks that first suggested a mere coordinate singularity and replacing them with a calm atlas where geodesics flow uninterrupted. And on that atlas, 4 regions appear like quarters of a compass. Our universe and its black hole, another universe and its white hole, a symmetry you can trace with your finger and feel the tug of a promise in, even as reality reminds you that maps are models, and models are houses with polite doors and hidden rooms. Enter Eddington-Finkelstein coordinates, which tilt the light cones and let you see that nothing physical obstructs the event horizon from the outside. That crossing is a local non-event for the traveler, and a global point of no return for the world, while on the time-reversed side, nothing can cross inward, because the orientation of light cones forbids entrance, a gate that swings only out, as if the geometry were a tide set permanently to ebb, and tides whisper of moons we cannot yet see. Penrose then folds infinity into reach, compactifying the edges so that the whole of eternity fits in a hand-drawn diagram where causal structure becomes visible at a glance, and within that glance you notice that white holes possess past singularities where paths originate instead of end, and that such a past is foreign to our experience of entropy and dust, a defiance that suggests the universe would have to be tuned with exquisite precision to allow such cleanliness to persist amid the noise we wake to. This is where instability arrives like a courteous intruder, because the slightest perturbation aimed at a white hole tends to be dragged outward by its very nature, but the past singularity from which it issues is allergic to even minimal contamination. And when you calculate the effects of a photon or a speck of dust toward that region, trouble magnifies, implying that white holes in a universe like ours would be delicate to the point of evanescence, a bloom that wilts at the touch of daytime. Rotate the black hole and the plot thickens, because Kerr geometry admits not only an outer horizon but an inner one, behind which the signposts of causality rearrange in unnerving ways, and the maximal analytic extension tempts with paths that loop through ring singularities into elsewhere, routes that, on paper, could be reinterpreted as white exits. Yet physicists like Poisson and Israel teach us about mass inflation, the catastrophic growth of energy density at the inner horizon triggered by scant streams of radiation, a chastening that turns fantasy back into caution. At electric charge and Reissner-Nordstrom geometries echo the same story with their own timbre. Inner horizons, potential traversals, and then the universe's message that ambient noise is destiny. A reminder that elegant symmetries live best in low-entropy gardens and have trouble in wildlands full of photons and dust. A message that does not forbid white holes, so much as suggests they belong to conditions more pristine than galaxies permit. A condition we might find only in the universe's earliest moments. And so some turn their eyes to the beginning, asking whether the Big Bang is a white hole by another name, or whether inflation, our idea that a small patch of vacuum expanded at a furious, smoothing rate, could be a white hole's polite alias, a description in different coordinates of the same exhalation, which leads to models where collapsing regions bounce in quantum regimes and seed new expansions. A genealogy of universes that would make our cosmos a descendant in a family tree rooted in forbidden places. Others prefer a single universe with a time-symmetric heart, where the Big Bang is not an explosion, but the midpoint of a larger, Janus-phase structure that expands in both time directions away from a state of minimal complexity. And in such a vision, white holes become metaphors for the outpouring of order in one temporal direction, a linguistic convenience that nevertheless nudges us to ask whether our prejudice for one-way time is a feature of biology rather than physics, a question that stirs like a breeze through closed rooms. While theory composes symphonies, observation deals in instruments, and the instrument makers whisper of signatures. A white hole event would not pull matter into a glowing spiral, but push matter out in a clean burst, perhaps with a sharply defined start and an absence of precursor, perhaps with a spectral shape distinct from supernova and tidal disruption events, a profile that could hide among fast transients we already chase, and so surveys widen their shutters to catch the sky in X. It performs too quickly to repeat on command. Fast radio bursts flicker across these conversations like strobe lights, millisecond detonations from distant galaxies whose origins remain a gallery of candidates. Magnetars cracking, neutron stars merging, cosmic strings twanging, and a few brave papers wonder aloud if a subset could be tiny white hole pops. The final quantum cough of evaporating black holes turned inside out. A story whose plausibility lives or dies on distribution, energetics, and repetition rates. A net we can tighten with statistics if we refuse to be seduced by name alone. Even more exotically, some propose white hole remnants as dark matter, an ancient population of frozen indigestible nuggets birthed in the high curvature theater of the infant universe, or in the depths of primordial black holes, islands of geometry that refuse to absorb and prefer to reflect the world, an idea that both charms and demands, because it offers testable consequences, microlensing, high-speed scatterings, subtle gravitational perturbers, and insists we measure with more patience than drama permits. Hovering above all, this is the information paradox, like a moon that pulls the tide of speculation. Because if black holes swallow and slowly evaporate, what happens to the book of their swallowed stories? And one reply is that at the end, when the horizon shrinks to quantum scale, a rapid conversion emits the archive in a window we could call white hole behavior, and the purity of that emission would be our lesson. A final exam the universe gives itself in unitarity that we might grade by catching a few papers as they blow past. The story thus unfurls in 3 quiet acts: classical geometry that sketches, quantum correction that edits, and observation that annotates, and between them, white holes remain as a possibility. That tests the sincerity of our love of symmetry without promising comfort. An intellectual companion that asks us to keep our telescopes steady, our models humble, and our curiosity awake, because in the dark, the loudest sound is often our own heartbeat waiting for an echo that knows our name and returns it. There is a place where classical certainty runs out and quantum grace begins. A plump, thin theater where the script of space-time is rewritten in a handwriting we are still learning to read. And in that theater, a bounce is easier to imagine than a break, because quantum pressures can oppose collapse and turn descent into ascent, which is how loop quantum gravity paints the interior of a dying black hole. Not a final singularity, but a compressed phase that eventually re-expands as if answering a held breath. Two voices, Haggard and Rovelli, gave this compressed phase a name that sounds like a weather report for a microscopic storm Planck star. And in their scenario, the black hole's core crystallizes under quantum gravity, suspends collapse, and later re-emerges as a white hole event whose clock runs differently for insiders and outsiders. A relativity magic that allows ages to pass outside while minutes pass within, setting up an exit that is delayed and sudden at once. A paradox that tastes like the future. In such pictures, the black hole does not evaporate to nothing but transitions, conserving information and reprocessing mass into an outgoing wave that refuses entry. A refusal that defines white holes more robustly than any poetic inversion could. And while the math is not yet a creed, it does produce signatures a patient sky could share. Brief bursts at specific energies, potentially clustered at late cosmic times. A pattern that data miners could hunt if they knew which haystacks to brush with their fingers. What we need, then, are catalogs of transients thick enough to hide a generation of theoretical children. And the universe has been generous, supplying gamma-ray bursts that flash and fade, supernova that bloom and dwindle, kilonovae that smolder with our process gold, and fast radio bursts that crackle like cosmic static with an agenda. And among these phenomena, we could insert a white hole candidate as a control story and ask what would make it stand out. A task that turns bedtime speculation into cautious survey design. Perhaps it would leave a neutrino trace without a supernova-like curve, or a gravitational wave memory without a chirp, or a polarization signature that refuses to rotate the way a magnetars would, or a repeated whisper that is astringently non-repeating. A paradox phrased as an absence of recurrence in a universe that loves to ring. And each of these possibilities can be tested with arrays we already own if we align our alerts and teach our algorithms to look for the odd shapes theory expects. Meanwhile, another quantum tradition string theory has built its own gondola for this river, floating ideas like fuzzballs in which horizons are replaced by tangled microstates that radiate like any surface, blurring the line between black and white by suggesting that nothing is perfectly absorbing and nothing is perfectly reflecting. A practical philosophy that would make white holes less like singular monuments and more like regions of strong reflectivity. A taxonomy that might be indistinguishable observationally from peculiar compact objects until a rare event betrays them. Then come the conjectures that draw bridges between distant shores. E equals EPR, the bold hint that entanglement and wormholes are two languages for one structure. And if that is true, then in a deep sense, every black hole that is entangled is also threaded by unseen corridors. And those corridors might, under certain conditions, manifest behaviors we have catalogued as white, a turn of phrase that invites care, but allows imagination to practice without accusation, an exercise valuable even when it does not result in a measurement. White hole remnants, if they exist, would be quiet, scattering rather than swallowing, reflecting rather than accreting, and their gravitational field could still lens background starlight in ways that betray their presence. Microlensing events with durations set by mass and velocity that surveys like the Rubin Observatory will harvest by the thousands, a treasury where anomalies can hide if they are shy. And the promise is that with enough events, an odd distribution will step forward and clear its throat. If a primordial population survived from the early universe, its imprint could thread itself through structure formation, seeding or deflecting small halos. Or it could display in the statistics of wide binaries disturbed by silent partners. Or it might be seen in the high-velocity tails of stars, kicked by encounters with compact but non-accreting masses. A forensic approach that treats the galaxy as a crime scene dusted for prints, more patient than triumphant, more ledger than trumpet, which is the right mood for this hunt. Beyond the Milky Way, High-resolution imaging of jets and disks has sharpened our priors. Event Horizon Telescope reconstructions draw the donuts we expected, exposing hot plasma swirling at the edge of no return. An image that does not forbid white holes, but does not need them. And yet even here, some seek subtle deviations. Photon rings that thicken or thin. Polarization that twists against simulation. Quasi-normal mode spectra and gravitational wave. After rings that carry harmonics off by a hair. Each hair a potential signature, not of white holes themselves, but of pathways that lead toward them. At the fringes, there are thought experiments that take the information problem and turn it until a white glint appears. Firewalls that burn in falling observers, islands in the entropy calculation that return information in time, teleportation protocols that reconstruct interior states, circuitry that suggests the outside encodes the inside without violence. And in each frame, a question remains. Does any of this require a later white exhalation? Or do we resolve our paradox without a final breath? A question that leaves its shadows across 1,000 pages. Among the whispering conjectures is a tiny, persistent rumor that a handful of transients recorded decades ago were too sharp to be supernova and too solitary to be pulsars, captured on photographic plates and early radio logs by observers who did not yet have names for impatience. And though the catalogs have grown more disciplined, the old notes maintain their charm, as if the sky had once cleared its throat to see if we were listening with the right kind of attention, a reminder that even silence has dialects we have not mastered. We stand, then, between blackboards and dishes, between rehearsed symmetries and messy skies, aware that white holes could remain an elegant absence forever and still teach us the contours of time, and also aware that a single burst, caught well, would redraw our diagrams in an afternoon, a knife of data that would cut through a tangle of hypotheticals and leave a clean edge we could run our fingers along in gratitude for the precise shock of being proven right, or, better, being surprised. The idea of a white hole tempts us toward all the doors that open backward, all the causeways where effect precedes cause, if you choose your coordinates rashly. And so we practice care with time's arrow, remembering that entropy, not equations, sets our sense of before and after, while white holes, if they live, would be entities whose boundary conditions enforce low entropy in the past, a strange request of a noisy universe that makes them feel like guests at a formal dinner in a house mid-renovation. Cosmic censorship, the conjecture that nature hides its naked singularities behind horizons, sits like a chaperone in this narrative, and white holes test its strictness, because a past singularity that ejects rather than swallows looks unruly by design, and one suspects that the same instincts that clothe black holes will cloak white holes, too, until they are rare edge cases wrapped in horizons we cannot cross, a suspicion that aligns with our experience that the universe prefers its power with filters rather than bare hands. Wormholes, which were bridges when we were young and tunnels when we grew bold, promise shortcuts where distances fold like paper, and in their traversable form, they require violations of energy conditions that physics grudgingly allows at quantum scales. A diet of exotic stress energy too sparse to feed architecture. Yet if ever nature arranged such meals, the exits of those tunnels would look white in the limited sense of refusing entry, a relative of white holes by behavior rather than lineage, a cousin who borrows your name without asking. Somewhere in this neighborhood live baby universes, buds budding from the stalk of a parent cosmos through the high curvature hothouse of a black hole interior, spaces that become entire places with their own coordinates and constants. And the white hole in that picture is not a thing in our world, but an inflating throat in another, a polite way for our universe to export entropy and import silence, an export ledger we cannot audit except by inference, which makes inference our primary craft. Turn back to the beginning, and there is an alternative overture, a CPT symmetric cosmos where time, charge, and parity flip at the origin to produce a mirrored twin, expanding the other way. A proposition that does not need white holes, but rhymes with them. because in it, the Big Bang is not a moment of chaos, but an interface of order, a two-faced coin with both sides smooth. And such smoothness is the white hole's favorite texture, a hint that symmetry is not merely aesthetic, but structural. Observationally, the romance of white holes has worn many temporary masks. Quasars that once seemed like star-sized white eruptions turned out to be black hole engines with global reach, jets that shoot at near light speed but are rooted in accretion and spin. Supernova imposters that flare and withdraw are massive stars losing shells and pride. Tidal disruption events that look like galactic lightning are stars unspooled into noodles and devoured. And in each case, theory learned humility and sharpened its search image by admitting the sky's penchant for misdirection. In the data age, machine vision patrols the torrent, classifying light curves and spectral lines with a patience no single human could muster. And yet, within that automation, there is room for the human appetite for wonder, room to flag the anomalies that do not fit, to devise features that reflect white hole expectations, to ask for cross-correlation with neutrino logs and gravitational wave triggers, to design citizen science pathways that turn 1,000 casual eyes into a single attentive instrument. Because sometimes, mystery is a labor pool. Gravitational wave astronomy, still new enough to be called young without irony, offers an avenue in its late-time tales, the ring-down of space-time around merged compact objects, where deviations from expected quasi-normal modes could signal exotic horizons, echoes that some teams report and others doubt, a debate that is both spirited and tender in its awareness of noise, a debate that sharpens the blade with which we might one day cut into a white-like signature, if the cosmos decides to humor our persistence. Within the solar system, tests of gravity in the weak field regime are too gentle to press white holes into confession, but there are whispers that deep within cosmic ray catalogs, there are particles with energies that should not have penetrated certain regions if known sources are all, a whisper we entertain only with strong qualifiers. Because the history of physics is as much about learning why anomalies are ordinary as it is about catching the extraordinary, and that memory keeps us sober even as we stare into the dark with intent. The philosophical air thickens whenever time runs backward in conversation, and white holes bring a heady fragrance of determinism tuned in reverse, of final conditions shaping earlier states like a movie edited from the credits backward. And in that air, we ask not only whether the universe allows such inversions, but whether we would recognize them if they were subtle, whether the statistical blur of billions of particles would wash out the choreography of a white hole until only a transitory blush remained, a blush we might yet learn to see. The longer the search continues, the more the idea of a white hole shifts from object method, a way of interrogating what we think we know about horizons, about the flow of information, about the role of boundary conditions in physics, about whether nature prefers initial value problems or likes a sprinkle of final value spice. And this method has already paid dividends by forcing clarity in our thinking about evaporation, about entropy, about why symmetry is a tool as well as a temptation, a ledger we balance continually. And still, in late hours when laptops hum and coffee cools, a researcher will scroll through a light curve and pause at a burst that starts too sharply and ends too cleanly, that refuses to echo, that arrives with a neutrino friend and leaves without a dust print. And the room will grow smaller, and the heart will quicken, and the cursor will hover over anomaly. And in that moment, white holes are not just an idea, but a taste on the tongue. A taste that insists we take another sip of the night. Across a century, the story of white holes has braided the strictness of geometry with the play of imagination, tying conferences to mountaintop observatories, chalkboards to cryogenic detectors. And in that braid, the aesthetic of time reversal has worked like a compass, pointing toward places where symmetry demands twins, even when the climate for twins is harsh, a reminder that beauty in physics is not decoration, but a guide that sometimes errs gracefully and sometimes carries a secret map behind its face. If black holes are the heavy punctuation of a galaxy's sentence, white holes would be the rare exclamations you hear and cannot echo. Exhalations that allow nothing to come in, only out. And if they exist, they will likely be brief and shy, small and sharp. The residue of quantum grace, finishing a catastrophe without tragedy. A mediation between collapse and law. And that makes the search for them a meditation as much as a measurement. A way of calibrating our instruments and our appetite for symmetrical closure. The catalog of candidates waiting for better theories to visit has grown crowded. Millisecond radio flashes with personalities. Thermonuclear outbursts on doomed dwarfs. Jets that processes and ignite like beacons with agendas. And in this parade, a white hole would not wear a neon sign, but a neutral coat. Its novelty residing in what it lacks as much as what it shows. An absence of accretion contexts. A refusal to repeat. A spectrum that cuts cleanly. A geometry of event that reminds us of a solution we once admired on paper. To translate that admiration into a search protocol is to choreograph community, to align radio and optical eyes, to bring neutrino ears and gravitational wave hands into the dance, to agree on what a candidate would look like before it looks at us. And such agreement is not trivial in a field rich with shallows and rapids, but the reward is a kind of gentleness false positives, forgiven because they taught us a threshold, null results cherished because they told us where not to look, patience cultivated as if it were a shared garden. Parallel to the skyward hunt is the ground-level work of thought, where quantum gravity frameworks are taught to speak in plain predictions, where fuzzball textures are turned into spectral fingerprints, where Planck star exits are translated into population curves, where CPT symmetric cosmologies are asked for specific anomalies in background radiation. And this act of translation is prayerful in its own way, a devotion to clarity that invites correction, a discipline that wears the calm of marshaled uncertainty. There is also an archive to tend, old plates and logs to redigitize, Cold War notebooks to scan for unlabeled flares, tapes to replay with modern filters, because sometimes the phenomenon arrives before the name, and our predecessors saw without knowing how to frame, leaving us breadcrumbs in the form of marginalia and penciled questions. And honoring those questions by giving them a new hearing is a kind of humility that science rarely advertises but often requires, a humility that keeps the door open without letting the night blow in. New instruments come with their own myths, and the square-kilometer array will gossip with the sky at frequencies we have only tasted, while Lisa will listen for space-time murmurs, too slow for ground-based ears, and Ruben will watch the optical night change, as if it were breathing. And in this widening of attention lies a quiet promise that if white holes wish to leave even a thin trace, we will at least be present to register the attempt, a presence that feels like companionship rather than surveillance. Between instruments and ideas sits the human element, the sleeplessness and the patience, the bias we fight and the wonder we keep. And white holes, as a topic, have a way of clarifying our posture toward mystery, because they ask for a tolerance of absence without surrendering the hope of presence, a willingness to be wrong in public, tempered by the skill of being precise in private, and that balance is a virtue in any age, a virtue that turns the search itself into a lesson about how to attend. The conspiracy of symmetry that first produced white holes on paper has no smoke-filled room, only the cool air of covariant equations that play fair when time is inverted. And yet in that fairness, we hear the romance of hidden corridors and mirrored halls, the sensation that behind the visible universe, there might be a backstage where endings are reversed and exits serve as entrances for a different cast, and whether or not we ever see one of those doors open, the theater they imply keeps us buying tickets for the night sky. Even if the sky never offers a white flare with the right pedigree, the work does not revert to silence, because the same techniques will sharpen our knowledge of black holes, of neutron starquakes, of magnetar tantrums, of cosmic rays that still climb stairs we do not see. And the discipline of searching for the unlikely without self-deception is a craft transferable to every other corner, A craft that, when practiced well, leaves our instruments more tuned and our questions more musical. Some evening soon, a notification will arrive at an odd hour from a telescope with a kindly name, carrying a light curve that looks like a clean sigh. And a few people scattered over the continents will look up from their screens and step into hallways and feel the air, as if the universe were about to speak in a language we have practiced but never heard. And whether or not the syllables say white hole, the moment will join 100 such not quite moments and make a continuity of attention that is its own reward. Before you drift into sleep, remember mystery is never truly lost, only waiting to be found. If you enjoyed this journey, subscribe for more relaxing ancient mysteries, and let your curiosity guide you deeper.